What we're going to do first is go over the frequently made mistakes for assignment 3A. Many people did very well on that. Good job. Some people did abysmally bad on that. Not such a good job. If you're doing very poorly, you're just not paying attention because it's really not a hard assignment at all. So make sure that you watch the video, come to office hours, and also, this goes for everybody, make sure you run the unit tests. A lot of people still are not doing that. Everybody who's doing poorly is not running the unit test because the unit test will catch almost everything that, well, not everything, but an awful lot of things that are getting people huge amounts of points off on their assignments. So let's start by taking a look at some of the methods. This is the async, some of the async being methods. So this is execute on executor. The purpose of this method is essentially to take the countdown, latch, and cyclic barrier and thread pool executor and use them to get things up and running, and using the async task that's used as the implementation of async being. A lot of people are doing some very strange things here. So as the name suggests, by reading the name of the method, execute on executor, you should not expect to be calling the execute method on the async task, which, as you recall, always runs in a single thread of control. So if you do that, then you're completely not getting the benefit at all from using a thread pool. So you need to use a different one. Also, I don't know what this thread pool executor get queue.element is. That's obviously not the right thing to do. Here are a couple other things. Make sure that you use the factory method rather than making an async being task directly. It's just a little cleaner. You can make changes and only have to make modifications in a single place. Don't be passing in magic numbers to execute on executor. You should be using one of the helper methods, like get being count, for example, in order to tell you how many things to do. Don't be hard coding them, because then if you run the test and you don't have 10 beings, then you're obviously going to get really bizarre results. So think a little bit about that. This one makes absolutely no sense whatsoever. The whole purpose of doing the async task is to use the pool of threads that comes from the thread pool executor. So it makes no sense at all to create a new thread directly and then call async task do in background. That is mind-numbingly convoluted for no particular reason. So go back and watch the async task videos if you're having problems with that. It's all described there. This is a minor thing. You don't need to have a temporary variable when you do something like this. Just return it directly. So this is classic Java, C, C++ bug. What's wrong with that line of code? What does it think it's trying to do? Joe? Yes, that's a permanent assignment. So what's the right thing to do? Right. So this is a very subtle and pernicious, evil Java, C, and C++ bug. The single equal is an assignment, so therefore you're updating that may interrupt running to always be false. So number one, so make sure you check that properly. And then this code makes no sense. So we're trying to cancel. We're trying to get things to shut down. We're trying to tell that the underlying async task stop running. And so calling await makes no sense whatsoever. And likewise, calling the hook method directly makes no sense either. So the purpose of cancel, as the name implies, is to cancel the underlying task. So please go back and watch the video on async task if you're having a hard time understanding that. It's really quite simple. This is a subtle problem, but you should not pass true in here. You should pass the parameter instead of true, because that might be a different value. Even if for the test it's always the same. And likewise, here's another strange result where cancel is trying to shut the whole program down, which is not what cancel is supposed to do. Please go back and read the specification of what cancel is trying to do. One of the things that we've been sort of cutting and pasting from each assignment is the acquire, Palantir, and gaze method, which came from the original implementation that we had back in assignment 1, I think. And by this point, you should figure out how to do it properly. If nothing else, figure out how to cut and paste it properly from what you had before. This is got a whole bunch of mistakes in it. So this code is supposed to handle exceptions properly. This code doesn't handle exceptions at all. And in particular, if an exception is called, the release Palantir method will not be called. So make sure that you set your code up to properly check this. This should have been something that you have done in earlier assignments. So if that's continuing to be a problem, make sure you go back and think about that. And you can go back and watch previous frequently made mistakes videos to see what is going on there and why that's wrong. So what's the purpose of on post execute in the async being? What's the role that it's playing? First of all, can someone remind me what on post execute does from a programmatic hook method perspective in async task? Xavier.
If you want.
Right. After doing background is finished running in a background thread, it returns a result, which gets passed in here as a string. And on post execute is a hook method that gets called back when things are done. So what is the role that on post execute is playing in our program? What are we using it for in the context of the Palantir simulator? 3. Right. So it's at a higher level than that. What purpose is it playing? What's it trying to accomplish? Bruce? Right. So it's basically telling the Palantir, the being manager, it's saying, hey, one of your beings is finished. And the way the barriers work, if you recall, is that there's a count, which is initialized to the count of the beings that are running in the background. And as each one finishes in its on post execute method, it's going to say, hey, I'm done. And when the final count of the countdown latch drops to 0, then the being manager knows, hey, everybody's done running. I can go ahead and shut down. I can clean up. So what's wrong with that call in on post execute, given that description? Right. So blocking on the exit barrier is actually what we want the being manager to be doing, not the being thread or being task. Okay, so that's wrong. Similar problem here. This is even more bizarre because it's trying to call the notify method. I think whoever did this read the comment that said notify, but it really should be more like inform or let the being manager know that this guy's done. So don't be calling notify. We haven't even really covered that in any detail yet. Here's a subtle bug. Assuming that this is the only code in this method, what is wrong with this code? First of all, what is the role of new thread? What is new thread? Exactly. So new thread is a hook method that gets called back by the thread pool executor when it needs to make a new thread, right? When we need a new thread to be in the pool, to have the pool thread count properly set, the thread pool executor framework calls back to the new thread factory method, which will turn around and make a new thread. So that part's correct. So, and what Tessa just said was very important. It wants to make a different name for each thread. And so this, of course, will always give back the same name because it doesn't change the value of the MID, which is the ID count. So you need to make sure that that's right. If you take a look down here, there are variations on this theme. A lot of people had various problems with this. You don't. What's wrong? What's wrong with this code, Bruce? Right. So increment and get has the side effect internally of updating the count by 1, so you don't have to reset it since it's already been set. And let's see. But actually, mercifully, this one will work. If it had been get and increment, then it would have been back to what it was before. Yes, exactly. So we got it by the skin of our teeth on this one. So what's wrong with this piece of code? It's not giving the name, right? And it's also not giving the runnable. So it's just making a thread that does nothing. So that's clearly not correct. Here was another problem. A lot of people did this. So, and this part here is not necessarily wrong. It's just that you don't need to do set name. You can simply use the 2-parameter version of thread to pass in the name. So you can do that. There's also other ways that are a little bit more simple than doing string.value of. You can also, say toString and stuff like that. And you don't need to say get and add 1. Just use the get and increment method, or increment and get, either one, as long as you use it properly. So those are people who had minor problems. Those were typically what they look like. So run simulation. Run simulation needs to do more than just have the barrier await. That doesn't make any sense. Some people had their heart in the right place trying to implement streams. You actually don't need to use streams for most of this stuff. You can use just good old Java 8 methods like for each. So there's actually no need to use getBeings.stream.peak.count. You can simply say getBeings.forEach. And I think I wrote the comments carefully, so it just said use Java 8 features. So that doesn't necessarily mean you have to go all the way to streams. Let's see. Oh, and for this thing, you don't use the thread pool executor directly. Instead, you're going to be using the async tasks to do all this stuff. So I'm not sure quite what this was trying to do, but it was wrong, because we need to use the async task methods. Another very common set of problems, a lot of people had the wrong count for being count. You have to think very carefully, how many threads are you trying to prevent from starting till they're all ready to go? Think through that one carefully. This value is also incorrect. A lot of people were making being count be the first param. That's actually not the right value. Hint, it's a 0. And then down here, again, don't be using the executor directly. Use the async task. That's the whole point of this thing. I'm not really even sure how that's compiling, but it's not correct. And putting this code here makes no sense. Doing the await calls here in begin being async tasks gazing. That goes somewhere else. I'm not sure what this code is doing, but it is also incorrect. The whole purpose of the assignment, please, please, please read the specification, watch the video. It explains all this stuff. The point of doing this is to use the entry and exit barriers. And I'm not sure exactly what this is going to do, but it's going to be a big mess. And it's not using the entry and exit barriers, so it's not doing things correctly. So don't write code like that. Use the entry and exit barriers instead. So I'm not sure where notify all comes in. Notify all is definitely not what you want to be calling here. That's something that comes from the underlying Java object that inherits the interface object. Not the right thing to do. We want to be waiting, not counting down. So that's incorrect also. Shut down now. You need to do more than just clear out the queue. I'm not even sure what that does. I'm also have no idea what this does. Set keep alive time. But that's definitely not what you want to be doing here. You want to be canceling the tasks. And this one is, I think it's clever. I'm not really sure exactly what it does. It's very complicated, but it's much easier than all this. You don't have to do anything this complicated. You just have to basically call for each and iterate through the list of async tasks and cancel them, passing in true. So it's much, much simpler. OK, so that was the set of frequently